Hello students. This is a video to supplement the 8th standard NCERT science textbook. This video, made for chapter 14 titled Chemical Effects of Electric Current, is made for students with two objectives in mind. 1. To demonstrate in a simple way the activities suggested in the chapter. And 2. To provide the fundamental concepts underlying these videos to give students a brief overview of the chemistry happening here. That being said, the overarching objective would be to get students enthused about chemistry. There is a whole lot of chemistry in our daily lives, and these activities here will provide you a good introduction to it. So the very first thing we are going to be talking about here is about good conductors and poor conductors of electricity. Good conductors of electricity are those materials which allow electric current to pass through them. On the other hand, poor conductors of electricity are those materials that do not allow electric current to pass through them. In the solid state, our examples of good conductors of electricity are metals like copper, aluminium, etc. While bad conductors of electricity would be wood, plastic, etc. But now we move on to the liquid state of matter, and the question we are trying to answer here is, do liquids conduct electricity? In order to find the answer to it, we need a tester, and of course, some representative liquid samples. On to the tester first. What we have here is a bulb, a 9 volts battery, and some connecting wires. You will notice that in the wires, which are copper wires, the end 1 inch on both sides is shaved off. This is to enable us making connections. A battery, as you know, has a positive and a negative terminal, and likewise, our bulb here also has two oppositely charged terminals. So with this description out of the way, here's how we do the connections. The negative terminal of the battery is connected to the negative terminal of the light bulb. The positive terminal of the battery is connected to a connecting wire, the other end of which is left free. And we also have another wire connected to the positive terminal of the light bulb, whose other end is again left free. Now these two free ends, one coming from the positive terminal of the battery and the other coming from the positive terminal of the light bulb, are our two leads for testing whether liquids conduct electricity. This question, whether liquids conduct electricity, is, as you'd recall, the question we are trying to answer here. So, prior to attempting to answer that question, let's check if our tester here is working. In order to do that, let's touch these two leads together, and a light glowing in the bulb would mean current is flowing in the circuit. And when we open the circuit, that is, remove the two leads from touching each other, the light goes off. This means there is no current in the system now. So what we have established here is that our tester is working, and this was the first activity, activity 14.1 outlined in the chapter. Let's now move on to activity 14.2. The objective here is to find out whether lemon juice is a good conductor of electricity or a poor conductor of electricity. Here are the things we will need for this activity: a sample of lemon juice and our tester. So let's insert the two leads of the tester into this beaker containing lemon juice. So here we are with the leads in, and what we see here is the light bulb glowing, which means lemon juice conducts electricity, or in other words, lemon juice is a good conductor of electricity. The underlying science here is that when the liquid, whatever be the liquid, between the two ends of the tester allows current to pass through, the circuit becomes complete. This current flow is therefore depicted by the glowing of the light. If the light bulb did not glow here, it would mean that the liquid under test is a poor conductor of electricity. The finding from this activity, that is activity 14.2, is therefore that lemon juice is a good conductor of electricity. Moving on now to activity 14.3. The objective here is to make use of the magnetic effect of electric current again to test whether lemon juice is a good conductor of electricity. The materials required for this activity are a magnetic compass, a small tray made of a poor conductor of electricity. Here we are making use of a plastic tray, some copper wire, our battery, conducting wires, and some insulating tape. So this is how we do this activity. We place the magnetic compass in the plastic box tray. Then we wrap the copper wire a few times around the tray, and now you would see there are two free ends to this copper wire. We now connect one end of this wire to the positive terminal of the battery and leave the other terminal free. Now we take another conducting wire and connect it to the negative terminal of the battery. This is a circuit here, and to check whether this is working, we connect these two wires together. The indication here would be if the magnetic compass shows a deflection, then the tester would be working. Now to check whether lemon juice is a good conductor of electricity, dip the two leads here into lemon juice. When we do this, we see a deflection in the magnetic compass needle, and this therefore indicates that lemon juice is indeed a good conductor of electricity. Now let's use our previous tester with some other liquids to determine whether they are good or poor conductors of electricity. The liquids we are considering here are vinegar, tap water, milk, and refined oil. So as before, we are going to dip the leads of our tester into each of these liquids one by one and look for the lighting up of the bulb. If the bulb glows, then our liquid is a good conductor of electricity. But the thing we need to remember here is that we should wash and dry the ends of the leads before dipping them into subsequent liquid samples. The findings from this activity are as follows. Moving on now to activity 14.4. This activity has two parts. In the first part, we will test if distilled water is a good conductor of electricity. We will carry out the activity as before. We will dip the two leads of our tester into distilled water. So as we dip the two leads into distilled water, we do not see the light bulb glow, which means distilled water is a poor conductor of electricity. Let's now move on to part 2 of this activity. In here, we will dissolve some common salt, which is sodium chloride, into the distilled water sample. And then we will test for the conducting nature of the solution. So now we have a salt solution. Let's dip the leads into this solution, and what we see here is that the light bulb is glowing. This shows that aqueous salt solution is a good conductor of electricity. Distilled water is free of salts and is therefore a poor conductor of electricity. When we add an ionic salt like sodium chloride into it, the salt dissociates and thus makes the resulting solution a good conductor of electricity. The overall findings of this activity are therefore as follows. Distilled water is a poor conductor of electricity, and distilled water containing dissolved common salt is a good conductor of electricity. Activity 14.5. In this activity, we are going to dissolve some substances in distilled water and find which of these solutions conduct electricity. The materials required here are distilled water, an acid like hydrochloric acid, a base like sodium hydroxide, and a small amount of sugar. So let's take these 3 beakers which are labeled accordingly Each of these beakers now contains distilled water. And to the first beaker here, let's add a few drops of hydrochloric acid. To the second, let's add a few drops of sodium hydroxide. And to the third beaker, let's add sugar and dissolve it well. So now that the solutions are ready, let's use our tester to find out which of these solutions is a good conductor of electricity. So when the leads of the tester go into the beaker containing acid dissolved in water, the light bulb glows. This means water containing a few drops of hydrochloric acid dissolved in it is a good conductor of electricity. The same thing happens with the second beaker, which means water containing a few drops of sodium hydroxide dissolved in it is also a good conductor of electricity. But in the third beaker, the light bulb does not glow. This means that distilled water containing sugar is a poor conductor of electricity. These are the findings from these activities tabulated here. In effect, what we have seen here is that liquids that conduct electricity were solutions of an acid or base. And if you recall from the previous activity, solution of a salt also conducted electricity. So we conclude here that solutions of acids, bases, and salts conduct electricity. Activity 14.6. What effect does the current produce when it flows through a conducting solution? This is the question we are trying to answer in this activity. The materials required here are 2 iron nails, water, dilute acid or lemon juice, connecting wires, a battery, and a beaker. This is how we assemble our setup. In the beaker, let's take water and add a few drops of dilute hydrochloric acid or a few drops of lemon juice to make the water more conducting. Both our iron nails here function as our 2 electrodes. We need to connect both these electrodes to each terminal of the battery through connecting wires. Once the connections are made, after some time, we notice gas bubbles near the electrodes. These gas bubbles are indicative of a chemical change taking place in the solution. The passage of electric current through a conducting solution causes chemical reactions. As a result, bubbles of a gas may be seen on the electrodes. Some other changes that might be seen include deposits of metals on the electrodes or a change in the color of the solution. The exact nature of the reaction that takes place would depend on what solution and electrodes are used. These are, in essence, some of the chemical effects of electric current. Activity 14.7. Have you seen gold-coated ornaments wherein a layer of gold has been deposited on jewelry made of silver or not so expensive metals? Or perhaps if you have seen a brand new bicycle, you notice the shiny wheel rims. But if by scratching the coating comes off, you see a not so shiny surface underneath this coating. These coatings of one metal over another are obtained by a process called electroplating. The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. This is an example of chemical effect of electric current. Tin cans used for storing food are made by electroplating tin onto iron. In this way, food does not come into contact with iron and therefore is prevented from getting spoiled. Also, iron is used in bridges and automobiles, but iron gets corroded easily. So in order to protect iron, zinc is electroplated over it. In this forthcoming activity, we will be performing a simple electroplating experiment. The materials required for this are two copper plates or one copper plate and one iron nail, copper sulfate solution, a battery, connecting wires, and a beaker. In our beaker, we take the copper sulfate solution. We will suspend our two electrodes, one copper plate and one iron nail, into the copper sulfate solution by means of insulated wires and a glass rod. The copper plate is connected to the positive terminal of the battery, while the iron nail is connected to the negative terminal of the battery. Current is allowed to pass through the circuit for some time. Now, when we remove the electrodes from the solution after some time, we notice a deposit of copper on one of the electrodes. This electrode was connected to the negative terminal of the battery. And in our experiment, this happened to be the iron nail. Now, what is happening here is when electricity is passed through the copper sulfate solution, it dissociates into copper and sulfate ions. The free copper from the solution gets drawn to the electrode connected to the negative terminal of the battery and gets deposited there. From the other electrode, which is a copper plate, an equal amount of copper dissolves into the solution. This means that loss of copper from the solution is restored and therefore the process continues. This brings us to the end of these videos made to supplement your chapter. If you recall, the primary question we were trying to answer here was whether liquids conduct electricity. What we have found is that some materials are good conductors of electricity, while some are poor conductors of electricity. We further found that liquids that conduct electricity are solutions of acids, bases, or salts. Our last two activities will help you recall that passing electric current through a conducting solution results in chemical changes. These resulting changes are called chemical effects of electric current. Two of the changes we saw here were in terms of gas evolution and metal deposition. And we saw in some detail an activity focused on electroplating. In the introduction to this video, I had mentioned that the overarching objective of making this video was to enthuse students about chemistry and to make them appreciate chemistry that happens in everyday life. Electroplating stands as a testament to that, with its applications reaching into various aspects of our lives. Finally, I hope, in conjunction with your chapter, these activities will help you understand the science that is happening here. Thank you for watching.